This video is for class 6 chemistry and today's topic is formula. The molecule of an element or a compound can be represented by a formula which is accepted universally all over the world. Now, why it should be represented by a formula? Because formula is the short form of molecule of an element or a compound. A formula is a short way of representing the molecule of an element or a compound. Now, why do we need to represent in the short form? Because of these three reasons. Number one, it saves time, it saves space, and it saves energy. Now, as you all know, the formula should be of a molecule. Now, there are two kinds of molecules. Number one, molecules of elements. So now, what will be the formula of elements? In case of an element, each molecule is made up of a definite number of atoms. The number of atoms in a molecule of an element is called its atomicity. Now, this atomicity has been already explained to you all in the previous video. If you haven't watched that video, please watch it and then again watch this video. While writing the formulae, atomicity is mentioned as a subscript, that means lower number, right? As a lower number, along with the short form of the element. Normally, the subscript 1 is not written. For example, we write the formulae of monoatomic element by simply writing their symbols. For example, helium is monoatomic, potassium is monoatomic, sodium is monoatomic, calcium is monoatomic. Helium is written as He, so He will represent its symbol as well as formula. K is the symbol for potassium as well as K represents one molecule of potassium. Sodium symbol is Na, whereas Na also represents a molecule of sodium. Calcium, whose symbol is Ca, also represents one molecule of calcium because all of them are monoatomic. Other examples will be like copper, zinc, etc. Number 2, if an element is diatomic, we write the subscript 2 along with the symbols. As you all know, diatomic means molecule having two atoms chemically combined. We write the subscript 2 along with the symbols. For example, hydrogen, as you know, the symbol for hydrogen is H, but this 2 here in the subscript will represent one molecule of hydrogen. So here the whole thing here, H2, will represent one molecule of hydrogen. Oxygen's symbol is O, whereas if you want to write a molecule of oxygen, we need to write it as O2. Similarly, nitrogen becomes N2, chlorine becomes Cl2 because they are all diatomic. Di means 2, so 2 needs to be written in the subscript. We follow the above method in writing the formulae of triatomic and polyatomic elements. Example, ozone should be written as O3, phosphorus should be written as P4, sulfur should be written as S8. So number here 3, 4 and 8 represents the number of atoms present in one molecule. This is how you write formula of compounds. As you all know that there are two kinds of molecules. One, molecule of an element. Number 2, molecule of a compound. Now, how to write the formula of a compound? Compounds are formed by the combination of the atoms of more than one element. Atoms combine with each other in whole numbers, which can be 1, 2, 3 or more. This whole number is the combining capacity of the elements. This combining capacity of the elements, afterwards you will know it is termed as valency. Right? You will study this in class 7, valency. Now, for the class 6 level, let us understand what does this paragraph mean. What is the combining capacity? Right? For example, water is a compound of hydrogen and oxygen. 2 atoms of hydrogen combine with 1 atom of oxygen always. two atoms of hydrogen combine with one atom of oxygen always to form a molecule of water. This is represented by the formula H2O. So this is the formula of water, which is H2O. Therefore, the whole number ratio in which hydrogen and oxygen atoms combine is 2:1. That means two atoms of hydrogen combines with one atom of oxygen. That means the combining power of hydrogen is 1 and that of oxygen is 2, because oxygen can combine with two hydrogen, whereas hydrogen can combine with only one oxygen. Therefore, the combining power of hydrogen is 1, whereas the combining power of oxygen is 2. Now let us look at the formulae of some common compounds like sodium chloride, calcium chloride, magnesium oxide. First, write down the symbols of the elements side by side that form the compound. Let us take the example of sodium chloride. So what we do is we write sodium and chlorine side by side. Under each symbol, write the combining power of the elements. So combining power of sodium is 1 and the combining power of chlorine is 1. Now how do you know that the combining power of sodium is 1 and the combining power of chlorine is 1? This will be given to you, okay, in class 6, right? But from 7 onwards, you need to know them, right? The combining power, that is known as valency actually. Then the third step, okay, you have to interchange the numbers, right? So this one will go to sodium and this one will go to chlorine. As you all can see, since the numbers are matching 1 in 1, right? So we do not write anything with the formula, no numbers in the formula. So NaCl becomes the formula of sodium chloride. Let us take another example, which is calcium chloride. So to make calcium chloride, we need calcium and chlorine, right? Now the combining power of calcium is 2, whereas the combining power of chlorine is 1. So we need to interchange the numbers while writing the formula. So this one will go to the subscript of calcium and this 2 will go to the subscript of chlorine. Hence the formula becomes CaCl2. We do not write 1 as we have studied earlier. Let us take another example of magnesium oxide. So as you all know, magnesium oxide contains magnesium and oxygen. The combining power of magnesium is 2. The combining power of oxygen is also 2. Now since the numbers matches, they can get cancelled out, okay? They will get cancelled out. Once they get cancelled out, that means there should not be any number in the formula. Hence the formula of magnesium oxide becomes MgO. Note, do not write down the subscript numbers if they are the same. For example, the formula of the magnesium oxide is MgO and not Mg2O2.